Welcome back to another STEM at Home. It is definitely spring. The birds are out, the pea plants have really grown, they're climbing up these trellises, and we're going to have some pea pods before too long. The topic for this week is space, and we're going to be learning all about different kinds of space, different planets, different things that are really far away but really cool. We asked some experts to tell us what they really thought was interesting about space, and I'm going to hand it over to them. I'll see you at the end of the video.
Hi, my name is Kimberly Maxwell. I work at JPL. I am the Science Operations Development Lead for the Mars 2020 mission, and this is my Mars Fun Fact. Have you ever wondered what things sound like on the surface of Mars? Yeah, I know, you'd have like seconds before you died, but imagine you didn't have to wear a spacesuit. What would somebody else's voice sound like? What would your favorite song sound like? Mars's atmosphere is a lot thinner than Earth's, and it's mostly carbon dioxide, not nitrogen and oxygen like we have here on Earth. Sound needs air pressure to travel, and Mars doesn't have very much of it, so you could stand there and yell at the top of your voice, and the person right next to you would probably be like, "What? I can't hear you." But the best part is, your parents would never tell you to use your inside voice.
Hi, my name is Dr. Robin Colanino. I'm an astrophysicist at the U.S. Naval Research Laboratory located in Washington, D.C. I work in the Space Science Division. Specifically, I observe the sun and the solar corona. I have a PhD in physics, and I primarily work to design and build the next generation of spaceborne telescopes to look at the sun and the solar corona. Right now, I'm currently working on the Punch mission, which is the next mission to observe the solar corona, which is the outer atmosphere of the sun, and then the heliosphere, which is the space that surrounds Earth and creates the solar system. I think the most interesting thing about the sun that people don't know is how dynamic the sun is. People think of the sun as relatively stable, and it's whether or not there's clouds that make your day different. But the sun is actually quite dynamic. It actually rotates every 27 days. And then it has an 11-year activity cycle, which determines how much solar activity it's generating. And the solar activity can directly impact people's lives on Earth. The solar activity can disrupt modern technologies such as GPS or our ability to transmit electricity along electric lines, or even can cause large amounts of radiation to affect navigation over the poles. So the sun is more than just, can affect your day more than just the sunshine outside. So thank you.
Hi, my name is Ryan Anderson, and I am a scientist at the USGS Astrogeology Science Center in Flagstaff, Arizona. I work on the Curiosity rover mission to Mars, and I'm also on the upcoming Perseverance mission to Mars launching this summer. And a big part of my job is working on the ChemCam instrument on Curiosity, which is a laser that we zap rocks with on Mars, and that we vaporize a little bit of the rock, and then we collect the light from that little spark that it makes, and we use that to figure out what the rock is made of, and that's part of my job. I also map Mars from orbit using pictures taken by satellites. And the thing that I wanted to tell you all about today is one of the things that I think is most interesting right now in Mars science, and that a lot of people don't know about. And that is that we know that Mars had water. We know that there are lakes and rivers and everything. So that's not the big question in Mars science right now. The big question is, how long did that water last? Was Mars really a nice place at one time? Was it warm and wet, like some people think? Or was it always cold and dry, and just occasionally it warmed up just enough to have some water flowing or a lake on the surface? So that's the big question. It's not the question of whether there was water, it's how often was there water? How long did the water last? And so that's what we're trying to figure out with these rover missions. All the rovers we've sent, they find evidence of water, but it's hard to tell how long it lasted. So The Curiosity rover is at Gale Crater working its way up through a bunch of layered rocks, trying to study how the water on Mars changed over time. And the Perseverance rover is going to a crater where we know there was a lake, and it's going to study some of the rocks that were deposited in that lake to, again, figure out how long was the water flowing, how long was that lake actually full of water, and try to piece together more information about the history of Mars by doing that.
Hi, I'm Dr. Michael Trimble. I'm a postdoctoral fellow at Yale University, and I'm a computational astrophysicist, which means I use computer simulations run on large supercomputers to better understand the universe. Now, I'm particularly interested in simulations like this that study how galaxies form and evolve over time. This is one of my simulations, and what we can do is follow a galaxy as it accumulates gas, forms stars, and grows bigger and bigger and more massive over time. And we can use these simulations to better understand and interpret observations of galaxies that we have from the Hubble Space Telescope or the James Webb Space Telescope in the future, and understand all the different physical processes that are going on to make galaxies look the way that they do. Now, of particular interest to me are the supermassive black holes that reside in the centers of galaxies like this one and like our own Milky Way. These are black holes that are millions to billions of times the mass of our sun, and are really interesting because we don't know a lot about them. Now, because these black holes are so massive, they can gravitationally attract nearby gas in the centers of their galaxies. As this gas falls onto the black hole, it gets very, very hot and very bright and emits a ton of light, such that this gas can actually outshine entire galaxies. And because they're so bright, it means we can actually detect the existence of these black holes even very, very far away. And so we can make observations like this. Now, this might not look super impressive, but this is an observation of the earliest detected supermassive black hole, the farthest away from us that we've ever seen one. Now, because light has a finite speed, detecting a black hole very far away is the same as looking back in time. So this black hole, a growing billion solar mass black hole that's very, very bright, it looks just like a dot here, is actually so far away that what we're seeing is a supermassive black hole growing in the very early universe, less than 1 billion years after the Big Bang. The universe is a very different place then. Now, observations like this are really interesting to people like me because it helps us better understand and constrain our ideas for how supermassive black holes grow and where they come from in the first place, which is still a matter of current research. So that was a little bit about me and my work. Thanks for listening.
Hi, my name is Lauren Edgar, and I'm a research geologist at the USGS Astrogeology Science Center in Flagstaff, Arizona. One of the biggest questions driving planetary exploration is to determine when and where did life arise in the solar system. So to address that question, my research is focused on sedimentary rocks on Mars and Earth. Because sedimentary rocks form on the surface of a planet, they record past aqueous and atmospheric processes, which are helpful for understanding environments that may have once been habitable. I'm also on the science team for the Mars Science Laboratory Curiosity rover, and my work involves both operating the rover and analyzing the data that it returns. And I think that one of the coolest things about the rover's landing site in Gale Crater is seeing just how Earth-like some of these ancient environments were. We've seen evidence for past streams, deltas, lakes, and dune fields in Gale Crater, and it really is a sedimentologist's paradise. Just this week on Mars, we successfully drilled again, so we're taking a sample of another ancient lake deposit and trying to piece together the story of how these environments might have changed over time and characterizing past habitable environments. And by looking at the thickness of these lake deposits and comparing them to Earth, we think that a lake or a series of lakes might have existed in Gale Crater for 1 million years. So it's 1 million years of an ancient environment that might have been habitable. And it's a lot of fun to look at these new images from Mars every day, and NASA posts all the images online as they come down if you want to check them out. So fingers crossed for another great day on Mars. Thanks.
Well, thanks so much for joining us this week. I definitely learned a lot, and I hope that you did too. Join us again next week. We'll have another video for STEM at home, and in the meantime, get out and enjoy the nice weather.